Hello, everyone. Welcome to the second talk of this session. We're going to learn how to use machine learning when you are not sure where to start. Please put your hands together for Julie Lavoie.
Are we good? OK, cool. Hi, I'm Julie Lavoie, and I'm going to talk about beyond scraping, how to use machine learning when you're not sure where to start. In particular, to cover this, I'm going to talk about the problem of how to extract the date of news articles online. Thanks to Sawhorse Media for letting me speak about work that I did for them. Just a note, I'm super jet lagged, so I hope what I'm saying makes sense. Feel free to come ask me questions after. I think I've lost about like 30 IQ points on the flight over here, which was 24 hours long. So let's say we want to get the date of one page, right? It's pretty easy. You just use, if you've done any scraping at all, it's pretty straightforward. Here we have the New York Times. You just kind of look where the date is in the page. You use your favorite sort of DOM inspector. Look at what type of div or what type of element it's in. Use like LXML, Scrapey, Beautiful Soup, whatever your library of choice is, and you can get the date that way. Sites use templates, so if you can extract one page from a site, you can typically get them all, right? So if I can get it from that one New York page time, I can usually scrape the entire New York Times. Getting the date of a second page or a second site, also pretty straightforward. I wanted to include a picture of that Yakuza guy because his tattoos are pretty sick, but I was like, I wonder if it'll be bad, so I didn't put the picture. But this is like Gizmodo, and so we do the same thing, right? We kind of see this thing was published on January 12th, blah, blah, blah. We kind of look at it with an inspector, and then we can say, okay, it's in like time tag, take that. So, our program just has two cases. If it's the New York Times, do this. If it's Gizmodo, do that. Pretty straightforward. But extracting the date of any page, that becomes a different story, right? We can kind of keep on adding cases for different websites, 10, 15 sites, 100, 1,000 maybe. What about 10,000? What about 50,000? Are we going to write a program that has like 50,000 cases? It quickly gets like unwieldy. So what now? Well, we could get people to do it. So you could use something like Mechanical Turk. It has an API. You can send tasks to real humans. It costs like maybe a cent per page. It's pretty cool because it's like, hey, we're programming humans, literally. It's pretty trippy to me that essentially human cognition in these types of tasks, has just become one kind of part of essentially a circuit in a kind of greater computation that's basically done by machines. So there's like a machine, your brain, a machine. That's kind of cool. The problem is, well, that's not really scalable. So let's say you process like 1 million+ pages per week. That's like 10 grand per week. Clearly that doesn't scale. And the quality is not always the best. I mean, for 1 cent per page, I'm not putting in my best effort either, right? Probably neither would you. Some foreshadowing, we're going to need this anyways. Not to insult Mechanical Turk. Like, a lot of them do a great job. But sometimes there's issues. You could get a programmer to do it. So as a programmer, don't worry, I'm including us as humans. We're just kind of like a subspecialty of humans. Don't feel bad. So you can get a programmer to like look at the data, see a pattern, write a program, right? So you could look at something like, well, if you look at the page and you see text that says published, you can extract a date from that. If you don't find it, look for like a div that has like a class that's publication date. You can kind of have a list of stuff like that, right? Solutions like this can be good first approximations. A lot of startups talk about before they went to machine learning, they started out with a kind of heuristics-based approach, and that's like often a good way to start. The problem is patterns can be more complex than human beings can understand. So for example, let's say I want to take a div element that has a class of date, but like, what if it's in the comments, right? The comment isn't the publication date, but often they have dates. So what do we do then? And then, well, what if it's also attached to an article, but it's like popular articles or related stories or whatever? It quickly gets kind of like a lot of these weird cases and subcases. But some foreshadowing is we're going to need this anyways. Okay, well, so we get out the big guns. We could get machine learning to do it. So machine learning is cool because it can see, quote unquote, a pattern that's more complex than humans can see. And it's interesting because it also includes both previous solutions. So I'm hand-waving about this, but we're going to do what's called supervised learning. So we're going to need humans to get examples of pages and correct dates to train the model. So we kind of need someone ahead of time to like give us input that we know about. And we're going to need heuristics to figure out what features to tell the model to pay attention to. So what are things that are significant about this problem that you should be trying to look for a correlation about? And so that is given to us by heuristics. So it kind of encapsulates both previous solutions that we're trying to like move past. But machine learning is a giant pain in the, it's an enormous amount of work. And so you should only use it if the volume of our data or the problem complexity is too much for previous solutions. So I was telling my friend what I was working on, and she said, oh yeah, I had some like stuff where I needed to parse dates out of a spreadsheet or whatever. Not a spreadsheet, but something. And she said, oh, I was thinking of hiring an intern, but maybe I should use machine learning now that you talk about it. And I said, well, how much data do you have? And she said, I have 2,000 results. So I said, 2,000 like total or 2,000 every day? She's like, 2,000 total. And I was like, okay, listen. At that point, you should literally just do it by hand. Like, don't even hire an intern. You're gonna have to tell them what to do. You're gonna have to clean up their work because they're gonna make mistakes. Like, I know you feel as a programmer you're too important to do data entry, but just do some data entry. Like, just do it by hand. So it's kind of like I do the data entry too. Like I do exactly because it's so frustrating to like give directions for like small amounts of data. And it's like they say, it's like the punishment has to fit the crime, right? It's like you need to adapt the complexity of your solution to the complexity of your problem. Like it has to be proportionate. So, okay, now that we've decided that we want to go ahead with machine learning, where do we start? And so I'm sure there's like lots of different ways to think about this. For me, like at the time I was a person, my degree's in math, I was a web developer, and then I was kind of the only person in my company that had any background in data, so I was just got assigned to do machine learning. So this is kind of how I approached it, right? Like I wasn't a huge expert, I was just like, all right, let's just try to think about it like logically, how could I approach this? So there's lots of different ways to do it, but this is pretty much just a presentation on how I did it, and hopefully you can get something good out of it. Or at least be entertained, I suppose. So I like to start these tasks by thinking, well, before I try to get a computer to do something, how would I do it as a human? So as a human being, when I look at a page, how do I know this is the publication date versus this is some random stuff? So, okay, let's look at this article. So this is something from CNN. The wedding crasher was a snake in the grass. Like, it was hard to find non-political articles for this. Like everything was like Trump, 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 Trump. I'm like, okay, I didn't want to incite any controversy. I was trying to find just funny ones. It was hard. So it's true, right? So how do we can see here, like the publication date is like, it says updated 909, like Wednesday, June 22nd. How do we know this though, right? Like we've been reading articles our whole lives since we were kids probably. So, we kind of know that, well, it's close to the title. The title is this massive text. It's close to the author. We know the author is the author because it looks like a human name. There's CNN, we know it's a news outlet. And then there's like a bunch of, it looks like a date, right? There's kind of like Wednesday, June, there's like words and stuff. There's numbers, excuse me. And it's not gonna be in like top stories, even if that would have a date, because that's not the main story. We know it because it's smaller and to the side. So there's 3 different types of cues that we can basically draw upon for this type of problem. So you can see language cues. So it says like updated, updated on, published on, et cetera, et cetera. And then we have like rendering presentation cues. So it's near the top, it's close to the title, it's close to the author. If you were someone that was like in graphic design school or in like web design school, they would teach you these things, right? Things that are big are more important. Things that are in repetition and close together are usually related. So they learn to communicate by outputting this information, and we process it and we know the meaning of it, right? Like anyone that's been reading articles for any amount of time. And then finally we have like markup cues, so not really read by humans, but are significant to us as developers. So stuff like it's in a div that has a class of pub date, it's in a time tag, it's in a meta tag, et cetera, et cetera. What was I gonna say? I'm sorry, I warned you guys about the jet lag. But so these are things that like a human just reading the article doesn't see, but for us it has a lot of information as developers trying to solve this problem. So these cues are actually so strong that even in a language that we don't necessarily understand, so personally, if you're a Japanese speaker or you read Chinese characters, set this one out because it's probably easy for you as well, but we can still kind of muddle through and probably figure out when was this published, right? We can kind of see like at the top there's like the menu bar, we can see like the kind of blue and light blue like Twitter, Facebook stuff, even though it's in Japanese, it's from like a Japanese publication. It's apparently about some eruption in Hawaii, I think. You can see the big text, right? The biggest text is probably the title, and then you see a bunch of numbers. So we see like 2018, 5, and like some stuff. If we were gonna bet our own money, we can kind of figure that's probably the publication date of this article. Okay, so for the Chinese speakers and Japanese speakers, like here's an even harder one. maybe that one was still easy for you. This is in Thai. And in Thailand, to make things harder, they don't have, they use the Buddhist year. So in Thailand, it's not like 2018, it's like the year 2500. Well, I'm gonna give it away, but it's like, it's a different year than us. I don't even, it's like, because it goes like, for us, it's the birth of Christ, I guess, and I think the Buddhist year goes from the day, I don't think it's the birth of the Buddha, I think it's the day the Buddha was enlightened, which was 500 years before. Anyways, kind of long story, but unrelated to machine learning. And so, just like complete side note. So I don't even really know what this article is about. I just like the picture with the cats. If there's any Thai speakers in the audience, maybe you can tell me later. I'd love to know, actually. But we can do the same process. So, on this side, we're kind of cheating. It's like English, etc. You can see, well, Facebook, Twitter, all that stuff. Probably the most prominent text that's not like in the picture is the title, right? And under that, we still see it's like 1702. That looks like a time, right? And then there's like 2561. Let's take a wild guess and say that's probably the publication date. So even like we have no idea what's going on, you can kind of, these cues are so strong we can figure it out. So just as a random side story, I really like cooking Korean food, and I had a Korean roommate, and he showed me how to order groceries from this website that was Korean only, and it was mostly pictures, so you can even use Chrome to like translate it. But like basically, cues of design of the web are so strong that I like every week for like, I don't know, 6 months, I ordered my groceries from this like Korean only website, because I could sort of figure out, oh, it's probably like put in the cart, or like take this, and be like, okay, this looks like I should put my address. And so like these things are really strong. Even when we can't depend on language, we can kind of do a lot. And for a while, like I was always really surprised, because I think only Korean speakers like ordered from the site, and was like, whoa, who are you? Like when he came to deliver groceries to my house. But so this is all to say that there's a lot of information that we can draw on to solve this problem. Okay, so now that we've kind of thought about, as humans, how do we think about this? Now we have to kind of bring it back to, how do we conceptualize this in terms of machine learning? So for myself, what I kind of found the most difficult in terms of solving problems with machine learning is, how do I set up the problem in a way that machine learning can answer? Like that's, the phrasing of it is sort of critical. And it's sort of like people say about jokes. It's like you set them up and I knock them down, like, kind of comedy team. You have to set up the problem in a way that machine learning can answer it. So I was very much helped at the time where the CTO I was working with basically found this research paper online, and that's what I ended up implementing, which kind of gave basically how they follow this. I do not recommend implementing a research paper in machine learning as your first production machine learning project. Just by the way, pro tip. It was definitely interesting, but not that easy. Just to give like quickly some terminology, I am being a bit hand-wavy. Like if this makes no sense to you, I'd be happy to explain more later. We're going to do what's called supervised learning, and we're going to phrase it in terms of a classification problem. There's all kinds of different types of machine learning and types of ways to do it, types of problems, etc. So supervised means, in our case, we're going to need actual people to look at pages and say, this is the publication date for it. And then a classification problem means, in our case, that it's not enough to say, kind of what I was saying about phrasing, it's not enough to say, what's the publication date of this page? That's too vague. There's kind of nothing in there for machine learning to kind of dig its claws into. So we're going to phrase it in terms of, does this DOM element contain the publication date for this article or not? So it's a kind of subtle twist in phrasing, and it's a classification problem because we're classifying DOM elements that come from the page, of course, into this has a publication date, yes or no. So we're kind of like putting stuff into categories. That's why I call it the classification. So broadly, here are the steps that we follow. Again, I'm kind of, like there's a lot of nitty-gritty. I'm kind of giving a bit of an overview. You can feel free to come and see me if you want to know like very like detailed code or stuff like that. So the steps we're going to follow for training the model is we're going to get a bunch of data, which is basically HTML pages and the publication date that is correct. For each of these pages, we're going to get all DOM elements in the page that contain a date. This is a weird intermediate step because the problem is a little bit weird, and this kind of comes from the paper, but yeah, like I'm not sure how to explain it. It's just that's how it's done, and it's just a bit weird. And then we're going to calculate features on each of these chunks. I often say chunks instead of DOM elements because I just got tired of saying DOM elements like 78 times per minute. And features are going to be things that we tell the model to pay attention to. So like, does it contain the word published? Is it a link? Stuff like that. And then we're going to train the model, which basically we just tell the library to kind of run the training thing. So step one, getting data. So I like this little whale because I feel like that's how we are in the data age, kind of just consuming all this data all the time. So Charles Babbage is the father of computer science, and getting correct data as a means of getting correct input, does that mean I have 10 minutes or I have 10 minutes left? Oh my God, okay, I better hurry. All right. Okay, whoa, okay, let's speed up. I was trying not to speak too fast because I tend to be really hyper, and now maybe I did the opposite. So, okay, so Charles Babbage, someone told, let me start over. This has been a problem for a long time. So he's the father of computer science. He's speaking in the 1800s. He basically invented the beginnings of computer science. And people asked him, hey, listen, if I put in wrong data, can I still get the right answer? And he's just like, the 1864 equivalent of WTF. He's like, I'm not rightly able to apprehend the kind of confusion. I mean, I love his answer, because whenever someone asks me something really out of left field, I'm just like, I don't even know what that question's about. I just think of Charles Babbage. And so he says, I'm not rightly able to apprehend the kind of confusion of ideas that could lead to such a question. So it's like, if you want to get a right answer, you got to start with right data. So basically, the data for this looked like a big CSV with a bunch of URLs. I asked people on Odesk, I think they changed the name now, to look at the page and enter the date in the CSV. It looked like this: URL, publication date, downloaded all the pages. People are often wrong, so I found what I did was I got 3 people to fill out the same data, and then I took the result only if they all agreed, and then I just ditched the ones where they didn't agree. The second you start working with data, you'll quickly realize that the more data you have, the more problems you have. So just random sampling of problems that I had. Sometimes you download the thing, people enter a date, but the web page has gone CSV in between my downloading it. Articles have a date when viewed in the browser, but when you download the requests, it uses React or something like that, so without the browser, there's no data in the DOM, so then, again, it shows up as nothing. UTF-8, I hate UTF-8 with a fire of 1,000 suns. I could literally give 10 talks. I could use up my 10 minutes on, how much I hate UTF-8. Sorry if you've worked on UTF-8, I'll buy you a drink later, but I'll still hate UTF-8. Basically, I tell people to drop results that are just like a stock code or something weird. I tell them to put n/a. I wouldn't do that anymore because that's prone to error because people miss the slash. But then they just enter every possible iteration of a misspelling of this, so then it doesn't get dropped, and I have to go and clean it. It's super annoying. People just enter incorrect results. I mean, when I do it, I make mistakes too, so of course all other people do. Okay, so now assuming we have a bunch of correct data, so for each of these pages, what we're going to do is we're going to all DOM. I'm sorry, do I have 10 minutes or I've spoken for 10 minutes? I have 10 minutes? Okay, let's roll. All right. So for all of this, we're going to get all the DOM elements in the page that have dates. This is easy for dates because dates have a limited format, so you can just use a regular expression in LXML. Here's just examples of stuff it looks like. I'm just going to kind of gloss over it. We need the DOM element and not just the data itself because of the markup info that gives us a lot of useful information. So next, on all of these kind of DOM elements, we're going to do feature selection. This is why it's a good idea to start with heuristics, because a lot of features can come from there. It just gives you an idea of what's significant, even though maybe you need machine learning to answer in what proportion. In my case, I just kind of looked at the paper, just listed their features, and that's what I did. Otherwise, it's actually a pretty hard problem in machine learning. So stuff like contains the word posted, modified, published, the header level, is it a link, is it bold or not, that kind of stuff. Pixel distance from top of the page. Then you train the model. If you're an expert in machine learning, you're just completely going to laugh at what I use. I was a complete newbie at the time. I used NLTK and naive Bayes. You could have used scikit-learn. NLTK is pretty good for text-based stuff. Scikit-learn is a lot more sophisticated, but it's a lot harder to kind of understand when you're starting out. And how I had to figure out what to use is I looked at the NLTK tutorial. I was like, okay, I can do this. I understand. Scikit-learn was like, OMG, I have no idea what this thing is even about. No. As programmers, maybe you have this experience as well. You're doing a tutorial hey, kind of Django, I'm going to build a blog 101. It's so great. I know what I'm doing. And then any actual production problem. This problem was exactly like this. I just love this picture. So now the model is trained, you can use it in production. We have to kind of do a few more steps because of how weirdly we phrased it. The model answer is, does this DOM element contain publication date or not? But our problem is actually, what's the publication date for this page? I'm just going to quickly skip over these because they're not super significant and kind of get to the stuff at the end. Essentially, we have problems of, let's say more than one DOM element gets labeled as this has the date. How do we disambiguate? How do we get the date from outside of the element? And then fine tuning. So I'm going to kind of skip 4 and 5 just because we don't have a lot of time. Basically, I take the first element that shows up as labeled as true, because it kind of just correlates with being at the top of the page. I tried a bunch of stuff, and that was the best thing. Regular expressions. I'm happy to explain this. It's not like it's necessarily obvious if you haven't dealt with them, but like basically use a regular expression. So fine-tuning. I did a whole bunch of fine-tuning in this, like improve the accuracy of the overall solution a lot. So I ditched DOM elements that lead to false positives. So comments, footers, JavaScript often has dates in the library. I'm saying like this is the latest kind of version. I do a bunch of post filtering, so I remove results that are obviously wrong, so stuff that's in the future, stuff that's in the past. However, an interesting thing is that New York Times has started to put historical articles online, so there's legit like dates, articles that are from the 1800s. So I had to like change my cutoff, now it's like from the 1500s. And then just like massive hack that I only thought of partway through, which is that if there's a date in the URL, it's always the publication date. So like literally just ignore this whole talk, ignore everything I just said. But of course, like any problem, you kind of learn this, like you go through this whole process, and then you kind of, many hours into it, figure this out, and then you feel like a complete idiot, and you're like, oh. I mean, of course, there's not always the date in the URL, but like this basically was a 10% increase in accuracy of the whole thing. Like not even at the model level, but at the overall solution in terms of like getting the date for the page. This itself was like a 10% like just jump in accuracy, this realization. Results. So basically, I'm being hand-wavy about like kind of how the results are split anyways, but it's basically about 88% precision, I think about 90% now, I forgot to change the slide, on articles from about 550 publications. The paper had 96% precision on their research data set, not ours. Reasons for this, well, I think I'm smart, hopefully that's true when I'm not super jet lagged. I'm not 5 professors in machine learning, especially not on my first project. They used a kind of more sophisticated algorithm as well. And some of them were differences between production and research. So, for example, I didn't implement headless browser features, so stuff like calculating pixel distance, because it was too slow for production parsing for us, kind of consulting with a CTO. We had like 100,000 of pages per day versus you just leave it chugging along in the lab. As well, for us, it's worse to get a wrong answer than no answer, so I like drop the result if I'm not completely sure. Lessons learned. I was the only person working on this kind of stuff at the time. I didn't have any friends that were like data scientists or anything like that. So I just kind of watched a lot of PyData talks to try to understand what's going on. So I thought I would kind of list some best practices, I guess. When you're setting up a data pipeline for this kind of project, basically go through the whole thing with a small amount of data first, which is not what I did, which I got all the data, realized it was all wrong, then had to write a bunch of code to like put it into the right format. It was just like a huge kind of set of time. If you're giving people like spreadsheets to fill out or stuff like that, give them examples. Often for crowdsourcing tasks, English is not necessarily their first language, so just be clear. Like don't use slang, idioms, don't like get complicated, fancy. Like just say things like very clearly. I'm very interested in this problem. If anyone has information, come and talk to me after, because I'm still kind of figuring this out. Basically, you can't rely on the kind of same kind of testing you have for like web apps or normal development. So I kind of started writing a lot of tools to debug the data pipeline at each stage, and they were just like different to kind of see like how, I think there's a talk about this like soon, I'm gonna go check it out. But basically try to figure out the different, like how the data should be at every stage and like write tools and spec to make sure that you can verify that's what's going on and where it's going wrong. I'm gonna skip over this. Okay, so finally, so just a finishing thought that I think someone posted on Twitter, I thought was cool, was machine learning is kind of a shift in your thinking. It's about sort of thinking statistically versus algorithmically. So let's say you write a program that's like, let's say you have 100 pages, 99 of them will have, say, the data at the top, and then one of them will have it at the bottom. So if you write something that's correct for those 99 pages, that one page will just be wrong, right? So it's just, I guess, one example of like a statistical approach to like solving problems. But let's say if you write with the assumption that the date's at the bottom, well, you're gonna get one correct and 99 wrong, which is pretty crappy. So machine learning in a way is kind of a search for what's right most of the time, and you try to improve like that number versus something that's algorithmically correct. So with a traditional computer science approach, let's say there's some case where it's wrong, that's a bug, right? Whereas for machine learning, it's like that's just the cost of doing business, and you're trying to kind of reduce that cost. So thank you to these people for helping improve this talk, and thank you to you guys for listening to it. I'm gonna take QA in the hallway after, feel free to come talk to me. And you can also talk to me. I like data and I like talking to people about their data problems. I also do remote consulting for startups on data problems. If you want to talk about that, that's totally cool. Thank you very much.